Data transformation. How to remove duplicates? Here we have a white color and the values, some duplicate values. So two columns. We can identify data frame dot duplicated. So it gives whether the data is duplicated. It gives it true, returns boolean. Only if you want to get a duplicated data, you can use this duplicated boolean condition in filter data frame. If you give any bracket, inside this square bracket, if you give any boolean condition, that is called a filter. You can use filter condition like this. So the duplicated column is getting rendered. So the last index, okay, last occurrence is getting rendered. This one is a duplicated, that's why it's getting. It has a list of items. We're checking one by one. The occurrence, the red is coming here, and here also is coming. First time it's not a duplicated value. If it is occurs second time, then only it's duplicated. That's why it's getting lost. Replacing values. How to replace values? We have a data frame. We have item, color, price. So here, instead of rosso, we have to change one value, red. Instead of this one, we have to change it to green. How to change? So in color format, there is a one dictionary object. So we have to set it which values want to replace with the new value. So what is the old value? What is the new value? So we have to give like this. After that, if you apply directly replace function, frame one data frame, it has a replace function. If you pass this dictionary, the new colors, it will change. Red and green, it's getting changed. It's getting applied. Directly, we can use replace function, but we can use replace function. The parameters should be what are the new value, old value. We have to specify properly. So here we have a series. It has some non-function. So here we want to replace numpy dot none is equal to 0. So all the non values is getting replaced with the zeros. So normally this one will use, because if you find a data frame, if you have a more non values, we can replace with the non values. In different ways are there, but the basic level is we can replace with some numeric number. 0 is a numeric, we can replace. This is a basic level, but while building model, we can see different, what are the different ways we can replace that non number. You see. Values via mapping. How to map the new values? We have item and color. We here we have item and color. One more column we have to map with item. We have a price. The default one doesn't have any price. We have to map the default one based on the item. Ball is this much price. Mug is, we have a separate another data frame, some another data we have. This everything is priced based on the item. So here we have this one, a frame, item and color is there. There is no price, right? So we have to add this column frame. If you add any new column, we have to data frame. If you add anything new, right, any string, if you give, that column will be added like this. There is no direct add function. If you give any data frame with square bracket any, if column is not there, what it will do is this new column will be added. So new column is getting added. What is the value for that column? So price is getting added. What is the price? The values you have to display, right? For that, frame item dot map. So here in the price dictionary we have item. So frame item dot map with price dictionary object. So item is getting mapped with the price dictionary object. This key and value per value is getting rendered like this. So mapping, we can fill values, we can add column with a if you have in real time, if you have two different data, but some items are common, one is a dictionary object, another one is a data frame, we can map it together. Otherwise, if you have a two different data frame, item is common, we can merge. Okay? But mapping also we can do. So rename the indexes of the axis. Frame, we have a data frame. Reindex, instead of 0 1 2 3 4, we have to give some rename indexes. So we can use rename. We have some reindex object. If you pass a reindex object, so everything is getting renamed. So frame dot rename. Read column. So read column. If you pass anything in the first parameter is the index. So the values are getting set it in the index. You want to change in a column also. Column is in the second parameter. So you have to specify this parameter columns is equal to re column, because the parameter we have to add in order wise. If you add the re-index, so you can pass it, because the first parameter is a default one. If you pass it, it will consider as only index space. But if you pass a column, so you have to specify the parameter names, columns and re column. So we have a re column. Instead of item, we have to change it to object. Instead of price, we have to set it values. So object and sorry. So here there is no object column name with the prints. Okay, that's why it's, price is getting rendered. There is item object. So rename with the object name, object string. So here rename, reindex. The columns all index also getting reindex. Rename. We can rename index and columns like this. With this first parameter is index, second parameter is the column. So if you want to replace rename only any particular column or row, you can do this one. Okay, so you can give like this. So till now what happen is, if you do any operation in the data frame, so the data frame original is remaining same, the new object data frame is getting created, and all the changes applied on the data frame it's getting created in the new data frame. So you don't want to create a new data frame object. So you want to do, if you want to do everything in the original data frame, you can use in place true parameters. In place, we can use this parameter mostly in all function. If you do anything, if you specify in place true, all the operation whatever you are doing, everything is getting applied with the original data frame. So next thing is in data frame, we have a data frame. We have to binning or discretization. What is the binning and this? So discretization, some discrete number, normally think discrete. There is a huge parameters, huge values are there in data frame. Height, there is a different height. Okay, so binning in the sense is kind of a bucket. 0 to 50, 50 centimeter number of heights, 0 50 to 100. So like this we can create some bins, number of, mainly in histogram. So there is a bin one parameter there, number of bins we can if you specify the number of bin, so it the data is total data is getting splitted into this number of bins. Here we have a result, and bins 0 to 25, 25 to 50, 50 to 75, like this. Result marks are there. So 0 to 25, different bins are there. So if you use a pandas.cut, results are getting splitted into based on the bin. First one's 12 comes with this 0 to 25, 12 value. 34 comes between 25 to 50. Normally, this bins in pandas, first one is this uh, braces, parenthesis, and next one is square bracket. Always, this first one is parenthesis and square bracket. So bins. So the cut function is used to split and categorize the values in the bin format. So if you use cat, this one is a cat categories. Categories means number of bins. So 4 bins, 0 to 25, 25 to 50, 50 to 75, 75 to 100. So all values are getting categorized based on this bin intervals. Okay. Here it has a 0, 1, 2, 3. Okay, this index categories have this index 0, 1, 2. Categories dot codes means it gives this index 0th index. This one is, if you see here, 0, 1, 2, 3 is kind of discrete value. There is no 0.5 like this. 0, 1, there is only 0, 1, 3, 2, 3, 4 categories. So discrete, kind of discrete type data type. Discrete is a set of finite number. So it has a discrete number here. So entire values is getting categorized based on bins, and we can still discrete those categorization like this. So that is called discretization. And binning is giving the frequent ranges, what range it lies, the values lies. So we can give how many values we have. Four, 0, 1, 2, 3, 4 different bins. 0, 1, 2, 3. How many values are there in this bin? How many values? Mainly already we have seen one parameters. We have a data frame. It has this one is a spam or ham. So spam or ham means we have a number of mail content. The final column is a label column. It has whether it is a spam or not spam. Spam, this mail is a spam, this mail is a not spam. Like this, we have one label. So how many spam or ham we have to list out. For that we can use value counts. Pandas dot value counts, it gives based on the categories. Here categories is only 4. So how many values are there? 0 to 25, 4. 4 values, 4 values, 5 values. Like so, in real time, it will be used like this to identify how many zeros, how many spam are there, how many not spam mails are there. So, if you have a data, we can get the counts through this function.